Alright, let's take a look at another application question. So here, Mia shoots an arrow upward with an initial vertical velocity of 11 meters per second from a platform that is 2 meters high. The height h in meters of the arrow after t seconds is modeled by the equation h of t is equal to negative 4.9 t squared plus 11t plus 2, where t has to be greater or equal to 0. Determine the velocity and acceleration of the arrow after 3 seconds. When is the arrow momentarily at rest, and what velocity does the arrow hit the ground? Okay, so if we're looking at, they tell us that the initial velocity is 11 meters per second, right? This actually isn't that relevant because we can actually determine that when we look at finding the velocity function, which is the first derivative of our position function. So we can understand that the velocity function v of t is h prime of t, or the rate of change of the position function in terms of the vertical axis with respect to dt, right? So if we look at finding the derivative of this function h of t, we basically get negative 9.8t plus the derivative of 11t is 11, right? So this is your velocity function, this is part A. The acceleration function is basically the derivative of your velocity function v prime of t, which is basically dv over dt, or the rate of change of velocity per unit time. So the acceleration function a of t is basically negative 9.8. Okay, this at negative 9.8 is actually pretty significant because this is actually the acceleration due to gravity, right? And this is actually constant on Earth, right? So the question was, the scenario was actually created to represent a real-world example of projectile motion. Okay, so the acceleration is negative 9.8 meters per second squared. When is the arrow momentarily at rest? Well, we know that the object is at rest when the velocity function v of t is equal to 0. Okay, so I'm going to take my velocity function negative 9.8t plus 11. I'm going to set it to 0. I'm going to move the 11 to the other side. You get negative 9.8t is equal to negative 11. I'm going to divide by negative 9.8 to both sides. Cancels out. T is equal to 11 divided by 9.8, which is equal to 1.122 seconds. Okay, so at this time, the velocity, the object is actually going to be momentarily at rest. Now, objects usually will become momentarily at rest when the object reaches its maximum height, right? So when any projectile reaches a maximum height, the object will be at a certain standstill. Initially it's going to be at rest at a certain instant in time, right? So it's a great way to actually calculate what the maximum height of the projectile is going to be, right? So if I plug in this t value into your function h of t, you can actually calculate for the maximum height of this arrow, right? Well, we don't have to really do this in this question, but that's just kind of good information to kind of remember for future references. Now, if we're looking at the third part of the question, right, what velocity does the arrow hit the ground? We need to figure out when the object will hit the ground, right? So we know that when the object hits the ground, h of t is going to be 0, so I'm going to let h of t equal 0. So we get negative 4.9 t squared plus 11t plus 2. Now you can notice here that this is equal to 0. You can notice here that this equation is going to be pretty hard to factor. Because it's in the form of ax squared plus bx plus c, we can, and this is equal to 0, we can actually utilize the quadratic formula. So we have x is equal to negative b plus minus b squared minus 4ac over 2a, so that's your quadratic formula. And I'm just going to plug in some of these values. So negative b here is negative 11, plus minus b squared here is 11 squared, minus 4 times a here is negative 4.9, and c here is 2, and 2 times negative 4.9. Okay, so if I crunch all this out, I'm going to get t is equal to negative 0.169 and 2.41. Now we can understand that, and I noticed here that I put x instead of t, right? That's just the general template of the quadratic formula, but in this case our independent variable is t instead of x, right? So it's really the same thing. So t here is negative 0.169 seconds, or 2.41 seconds. However, time cannot be less than 0, it has to be greater or equal to 0, so we can't actually utilize this value. So exclusively t can only be equal to 2.41 seconds. Okay, so This is basically the time when the object or the arrow hits the ground or the projectile hits the ground. We want to figure out what velocity the arrow hits the ground at. We plug this value in time. We know that the arrow hits the ground at 2.4 seconds, so the velocity at 2.41 seconds is equal to negative 9.8 times 2.41 plus 11. So we just plug that into our velocity function. So if I crunch this out, I'll basically get negative 12.618. So approximately negative 12.6 meters per second, right? Now the negative nature of our answer here, this implies that the object is moving down, right? If the positive velocity is if the object is moving up, the negative velocity is going in the opposite direction, so the object's moving down, and it hits the ground at 12.6